In this video for section 4.1, we're going to start talking about probability. Probability is the chance or the likelihood that a particular event will occur. Probability values are always between 0 and 1. If something has a probability of 0, that means that it definitely will not happen. And if something has a probability of 1, that means that it definitely will happen. An experiment is a process where you don't know what will happen ahead of time. So think about a science experiment where you don't know what the results will be until after you do the experiment. Flipping a coin is an example of an experiment in probability. Other examples include rolling dice and drawing a card from a deck. With these things, you don't know what you're going to get until after you actually do the experiment. The list of all possible outcomes of an experiment is called the sample space. So let's look at example 4.1. The sales manager for the Westside Drive-In is interested in analyzing the sales of its 3 hamburgers, the hamburger, cheeseburger, and bacon burger. He is interested in determining the sample space for 2 randomly selected customers. So let's list out the possibilities. One possibility is that both customers order hamburgers. I'm going to abbreviate hamburger with H, and I'm going to write them as ordered pairs here. So the first represents what the first customer ordered, and the second represents what the second customer ordered. Now, it's also possible that if the first customer ordered a hamburger, the second customer ordered a cheeseburger, and the first customer ordered a hamburger, and the second customer ordered the bacon burger. Now, what will happen if the first customer orders a cheeseburger? The second customer could order hamburger, they could order another cheeseburger, or they could order the bacon burger. And the third possibility for the first customer is that they ordered the bacon burger. Then maybe the second customer ordered a hamburger, the second customer ordered a cheeseburger, or they both ordered the bacon burger. So these are all of the possibilities. That makes up the sample space. An event is a collection of possible outcomes. So in example 4.3, we have an accounting firm conducting an experiment on whether audits have been completed. An audit could be classified as being done early, on time, or late. 2 audits are randomly selected, and the event of interest is that at least one of the audits was completed late. So at least one means it could be one of the audits or both. In this case, there are only 2 audits, so it can't be more than 2. So let's go through and list our sample space like we did before. We could have both audits completed early, first completed early and second on time, first completed early and the second late. And we can continue in the same way that we did with the burgers, and we should find 9 possible outcomes. So the question is, in which of these outcomes is at least one of the audits completed late? So let's go through and find them. We have this outcome, we have this outcome, where the second audit was completed late and the first was not. We have these 2 outcomes, where the first audit was completed late and the second was not. And we have this outcome where both audits were completed late. And so there are a total of 5 outcomes in that event. So my list would include these 5. Two events are mutually exclusive if they have no outcomes in common. This means that they cannot both happen at the same time. So for example, we have a company, Contract Works, that does assembly work for high-tech companies. Each product they produce can be rated as good or defective. If we select 2 products, are the events both products are good and at least one product is defective mutually exclusive? Well, yes, because it is not possible for both products to be good and for one of the products to be defective. If both products are good, that means that neither of them is defective. And so we can't have at least one of them being defective. So they are mutually exclusive. Another definition is independent and dependent. Two events are independent if the occurrence of one event does not influence the occurrence of another event. An example of this is when you roll a die. Dice do not remember what the last roll was, so even if you rolled a 6 on your last roll, your probability of rolling a 6 on this roll is still 1/6. Even if you get 4 sixes in a row, your probability of rolling a 6 on the next roll is still 1/6. Two events are dependent if the occurrence of one event does impact the probability of the other event occurring. So for example, if we have the events, there is a snowstorm and Flight 473 is canceled. The probability of the flight being canceled will be higher if the first event has occurred. So if the event there is a snowstorm occurs, then the probability of the flight being canceled will change. It does not stay the same whether or not there is a snowstorm. A snowstorm means that there is a higher probability that the flight will be canceled. We have some notation here for probability, and that's P with parentheses. So we say probability of E is the probability of the event occurring. So we'll see that coming up right here. We have classical probability assessment, which is also called theoretical probability. This is calculated by dividing number of ways that the event we are interested in can occur by the total number of possible outcomes. So for example, the managers at a clothing store are holding a promotion where customers randomly select an envelope that contains a coupon. We have 500 coupons, 400 with a 10% discount, 50 with a 20% discount, 45 with a 30% discount, and 5 with a 50% discount. What is the probability that the first customer gets a 20% discount? So I would write P, and then probability of what goes in parentheses, so probability of getting a 20% coupon. Well, there were 50 20% coupons out of a total of 500 coupons. Now, I can simplify this fraction. In the homework, you're going to have to enter a lot of these as simplified fractions, not decimals. If I want to write it as a decimal, that would be 0.1. A relative frequency assessment, which is also called experimental probability, is calculated in a similar way, but our context is a little bit different because it's based on actual observations. So we divide the number of ways that the event we are interested in occurs by the total number of trials. So looking at example 4.6, we have a coffee shop that sells caffeinated and decaffeinated drinks. In the past week, 1,570 sales were for caffeinated drinks out of a total of 2,250. What is the probability that a customer will purchase a caffeinated drink? So this time, we're calculating our probability based on past results. So we have 1,570 purchases of caffeinated drinks out of a total of 2,250. And if we divide those two numbers, this fraction is going to be able to be simplified, but it's much bigger, so you won't see anything like that in the homework. But if I divide those two, I get 0.6978. So it's almost a 70% probability that a customer will purchase a caffeinated drink.